Hey everybody, it's Opa Dave. Today we're going to do a Rotary Encoder. This is again for a larger project. I'm getting the piece parts together for my new channel design that I'm going for. But we're going to model up the rotary encoder for the project. So here again we will start off with the board as our major plane that we're going to be working off of. So let's get some measurements for it. We are at 17.5 by 29.25. So let's go ahead and get on our front plane. We're going to do a drawing on it. You do a center point, rectangle, and we said we're at, what was it? 17 point what? Sorry. 17.5. And we are at 29.25. All right, and this is 1.6 millimeters. Yep. We also have got two holes in it that we're going to throw. Not that we're going to probably use them for anything, but hey, why not? Modeling is modeling, and let's go for as factual and actual as we can. It is not centered, so it is 2.45 millimeters in diameter. So let's set these two to the same, and oops, make that equal, and 2.45 millimeters. And let's also go ahead and change this to millimeters. Back to editing our sketch. And they are in line with each other. So let's ensure we get that. All right. And we've got 3.8 from there, here, and here. Let's go in. .8 millimeters. .7. All right. Now let's get our center to center on that. And let's get it from this side. 16.4. Oops, that did not work out. Oh, at least we still have this up. 16.35. There we go. And That'll do that for right now. Now let's get our 1.6 millimeter thickness. 1.6, 1. Okay. Now we'll put the rotary encoder on. This isn't the exact rotary encoder that I'm going to use long term, but this is what I have on hand. And it is a 20 pulses per revolution, so I'm good with that. And let's get on to sketch. Let's go ahead and put this not in the center, but down here somewhere. Let's get our measurements for it. The body is 9.5 by 9.5. .5. 9.5. Our height is 1.8. Oh, but we got to get our location correct on the board. That edge we've got 3.75. Oh, I got to re-zero this. Yeah, there's an issue also, making sure that, so then this actually isn't 9.5, is it? It is 11, it's actually 12 millimeters square, and the distance to the edge is 6.83. Let's say 6.85. And this is 12 by 12. And the edge to there is 1 millimeter. And now our height is what? 4.45. We'll just call it 4.5. That's close enough. And okay. Now let's take the nut and washer off, because we'll put that on later. So let's get, this is 8.3. Hello. All right. We want this centered on here, so let's go and put that. And get back to our and let's also include that right there. So let's throw our dimension on what we do know, which is this. And 10.65. And how wide is that? 2.5. Alright, so let's cut out this stuff here. Come on. Get out of the way. Thank you. Okay, and this is how tall. I can't measure that way with it. Well, that just don't seem to want to work that way, so I guess we'll do it the way that's more prone to error. So we'll call this 2.5 millimeters. Oh, 2.2 millimeters, excuse me. Let's extrude that. 2.2. Alright. Now we have our threaded area, which is 6.75 in diameter. So it is how tall? 6.8. So we'll go up 6.8. Then we have a small gap in between here for the button push. So we'll throw it in, not that we need it, but like I said, why not? We're already here working, so hey. So it's 0.65 millimeters. I don't know if we can get a diameter on this. No, we can't. But we can get kind of an idea of what the diameter is. We'll call it 4. Come on. I truly don't know if that is what the diameter, but you know, we'll just call it that because we can. Like I said, I'm not building this part, I'm just using it. At this point, I really am putting a little too much effort into it itself, but oh well. Alright, now comes our rotary shaft part. What's our diameter on it? 6.25. And it is 12.35 tall. All right. Now let's put our D pattern on it, as they call them, a D pattern. And let's go ahead and get on that surface. We're going to sketch. We're going to convert the entity on that, and then we're going to draw a line through it. Oh, I don't want to be on that particular line. It may be in the right place, but I don't know. So let's come down a little bit further, and we can adjust that as we need. All right, so let's see what our D pattern is. It is 4.5 from the flat to the outside. So what we're going to do is we're going to put a point on here, make it easier for dimensioning. I don't have to go through a bunch of menus to get there from here. So we do 4.5. All right. So let's trim up what we don't need. We don't need this, we don't need that, and we don't need that. Oop, I just went the wrong way. Let's go back. There we go. Now let's try this again. Let's trim our entities. We don't need this side, this, or this. There we go. And how deep does this go? $10 millimeters. So let's cut down. $10 millimeters. Okay, so here we have our rotary encoder. On this end here, we need to put our headers that we're going to be utilizing. So we need to put a rectangular block, and that will be somewhere right in here. We have 12.5 in length. We also have our 2.5 and we are .45 from the bottom. It's probably more like 1.5, but it doesn't matter. Oops, I missed an edge. There we go, 1.5, and we are 0.8 from this edge. And we'll extrude this 2.5. Oops. Okay, now we come on top. Let's start putting our pin information in. I'm going to put a small pin here, and we'll put us up a centering line to go from here to centered on here. Let's make this vertical. Let's also make this 1 millimeter. Oops, not 11, 1. And remember this from the last unit we just did. These are 0.6. Yes.
I wanted to know, what are we doing?
Sorry, everybody, I'm back. That was my sister-in-law. All right, change this to 0.6. Okay. Now we'll finish this sketch here. Now I need to install a plane at, where we are? Here we are. Reference geometry plane, and we want it the center of that, so 1.3, and we need to flip the offset back that way, and there we go. So now if we get on this plane, we're going to draw on it, and we're going to come up from here, here, go out, and from, come on, zoom in, here to here is, what was it? Six millimeters, and from the top of that to there we have 2.12. We also need to subtract half the distance from that surface to the center of that pin. Okay, apparently we are not in the mode. Let's actually turn this off too. I'm tired of looking at it. It has served its purpose. Now, here we go. We had 2.12 minus 0.6. And yes, you can do math inside of your dimensioning. And then we also need to put in a fillet. We're going to call 0.25. No, that's not big enough. That's right, it's 0.75. There we go. And call that good. Call that good. Get out of the sketch. Come on. There we go. Now, we shall take these two and turn them into a sweep. Now we will come in here and we will throw a chamfer on the end of that, and we'll call this 0.2. Actually, yeah, that's enough. Not that it matters any. Okay, so now we take this, make this a linear pattern going that direction, and we know that there are 100,000 spacing, so 2.54 millimeters, and put 5. And there we go. All right. So that we have an idea of what we're plugging into on here, let's just throw some text. So let's come in. We need a center line. We'll throw some dimensions on these in a second. And you'll see what I'm doing here as soon as I'm done. Alright, so we're going to ensure that all of our text is 1 millimeter from that edge. And what we're going to do also to ensure that we're centered, because hey, why not? We're going to go from, well, let's do it a different way. Let's actually use the center of that. Now if we take this, draw this to there, take this, make this horizontal. Now we're ensured that this is centered on that. Now we'll take this and set this to 2.54 and do that for the remaining ones. Alright, what we have on here at the top is ground. So let's throw some text on it. And GND. We're going to put it up against that edge is what we want. We're going to change this to Arial. And probably go to 5 points. Yeah, 5 points will work. There's ground. This is plus. And we need to change that. All right. Next one down is SW. You know, one of the projects we're going to do on this channel also is we're going to create a wireless recording light so that when I'm recording, people outside of my office will know and not to come out here. So we'll see, but we shall see. Arial. And man, my office is warm. Even though I got a new, quieter fan, it's still warm out here. And I do have HVAC coming into this, my office. But my office doesn't have all of the insulation that it should. It's a 1980s home. And even though I've put a lot more insulation in the attic and stuff, I can't do the walls. And so but summer's almost over and it'll start cooling down and it'll be more comfortable out here. Okay, we have our text and we're just going to call that insert curve split line on this surface with that. There's our text. And there's our rotary encoder. Now what we're going to do also, we're going to put our washer on, but we're going to put it at the distance we need. So we're going to insert reference geometry, a plane. Our panel material is 3 millimeters thick. So we'll set that at 3 millimeters. And we have our plane selected. We're going to start with a circle, and we'll make sure we get the center of this. And I don't know how big our washer is, so we'll take a quick measurement. And it's tiny, but we still need to add it because we are going to use it. And we are at 11.4 millimeters. And then our inside is what? Not that we really need an inside on it. Yeah, we're not going to worry about that. We do need a thickness, though, and it is 0.3 millimeters tall. .3. All right. And now on top of this, we've got to put our hex nut, which is right there. Let's get our center point. All right. Let's lock this into that direction. Not that it matters, but we like turning everything black when it comes to defining our drawings. It is 9.9 by 2. So we go .9, and now we're going to extrude this 2 millimeters. And here we have our, we got one more thing, two more things left to do. On this face here, we're going to put our, we have a small alignment tab right here, and we're going to put that on. That is there to keep this, the body from spinning. You normally put a small hole or a machined recess that this will slide into, and then it will keep this from rotating on you. So we shall add that in right now. All right, what do we got here? Let's put that nut down. We don't need it anymore. All right, we have, it is 2 millimeters wide. Come on. Now let's center this on this edge. So now we'll take this. Now we're centered. And This is 12.6 out from this other edge. So we go from here to here. We get 12.6. All right. And let's get our thickness on this, which is probably the 0.3 again. No, it's 0.4. Actually 0.35, but we'll call that good. So, seeing that this is in line with this surface here, with this one, so we're going to go the opposite direction, and we shall change this to 0.35. All right. Now let's go up here and grab this. And we get on here, get that point, come down, call this 0.35. Yeah, I'm just tired of this being me quicker than what the computer or mouse can handle. And it is 2.7 millimeters tall. .7. There we go. Now, our last thing we have to do is install our drawing that we need for our cutout and for our tab. So, the question being is, do I want the hole to go all the way through for the tab or not? So let's draw a center line on here, here. See, now here at this point, you'll come up and figure out, do you want to do a circle, or would you rather do a machined hole or a drilled hole? Let's also turn this into a piece of construction geometry. And we'll say 2.25. That looks pretty decent. Our hole diameter for our threading is, we'll call it, what? 6.9? Sounds decent to me. Oh, I turned it off. .9. Okay, so there are our two cutouts that we need for our panel. This could be a machined all the way through hole, or this just could be a recess that needs to be machined into our 3mm panel. We're just going to have them, because this is going to be laser cut. My supplier for sheet metal, I use them exclusively because their prices have been fabulous. Their quality is awesome. So we shall call it a through hole, and then we'll just make sure we get a big enough nut to cover it. Not nut, but we call it knob for our Okay, one last thing we need to do. We're going to throw a chamfer on this edge, this edge, this edge, that edge, and that edge. Just because, why not? Okay, so here is our rotary encoder for our Arduino based instrument that we are going to be building. So let's save that. I don't know who the manufacturer is, so we'll just save it as a generic part, and we'll save it to the PC. And let's go to where are we at here? Oh, it must be on the D drive. Yep, our project. I don't know why I have two directories here. Oh well, doesn't matter. Working, docs, TDP, vendor, and I don't know, we'll just say Rotary Encoder. For some reason I know that. Hey Google, how do you spell Rotary Encoder?
Rotary Encoder is spelled ROTARYENCODER.
Okay, so there we are, Rotary Encoder. Now, let's save this in its form. We don't need this. We'll hide this. Actually, at this point, we're going to take it and name this. This is our panel cutout. And I have a plane someplace. Where's plane 2? Oh, there you are. And let's hide that because I don't want to see it. And we're golden. Now, if we really wanted to get cheesy, we could turn these pins gold and this black, but at this point I don't really care. And like I said, save and okay. So we are good with this for today. Thanks for tuning in while I took care of the rotary encoder for my project, and we will be posting another video very soon. If you like my material, give me a thumbs up and subscribe if you like. It's pretty early on in the development of this particular channel. So thank you for tuning in. I appreciate it. This is Opa Dave. We'll catch you guys next time. Bye.